All right, good afternoon, everyone. Welcome to the StorTrends Virtual Lunch and Learn. My name is Tyler Newberry. I'll be your host and moderator for the Lunch and Learn event today. With me is one of our Senior Solutions Engineers, James Dykowski. James will be joining us in just a moment, but I wanted to let everybody know a couple of things first before we got started. Number one relates to the pizza. If you are in one of those pizza delivery zones and requested a pizza in your registration, that pizza should be arriving actually right about now, 1 p.m. Eastern Time, if it hasn't already. Sometimes we found that pizza delivery people run just a few minutes behind or so. If they are running late, please be patient and be sure to let me know if your pizza hasn't arrived by like the 1:10 or 1:15 time frame or so, somewhere around there. Email is the quickest way to let me know if your pizza hasn't arrived on time. My email is tylerin@ami.com, and that'll be on one of the slides here. Actually, it's on your slide right now, tylerin@ami.com. Like I said, if your pizza hasn't arrived by like 1:10, 1:15 or so. Number two, please ask questions. We want to provide an interactive experience for all of you, so feel free to shoot your questions over via the Q&A communicator located at the bottom right-hand corner of your screen, and we will either answer your question live on air or we'll send you a message back on that very same Q&A communicator. And finally, if we experience any technical difficulties, such as losing audio or if the screen becomes a little bit grainy or something, please bear with us while we fix the issue. Technical issues are rare, but as I'm sure all of you know, they can kind of strike at any moment. But that's it. That's all I got. Let's go ahead and get started with this awesome presentation done by James on hybrid and all-flash storage. So, ladies and gentlemen, it's my pleasure to introduce you to your speaker for today, Mr. James Dykowski.
Hey, everybody. I hope everybody's having a good day. So we'll kind of go through everything and then follow this up with just a little demo, just kind of showing how our unit works and stuff like that, in the lab and stuff. So we'll get going here. So AMI, American Megatrends, this is actually our 30th year. And you can see we've got quite a few products. We've been around for a long time, and we're certainly not going anywhere. You may know us. You can see the little triangle in the kind of the center bottom left there. You've probably seen that on BIOS screens while booting computers back in the day. Of course, now with OEM businesses, basically it's that company's logo now. But we still are in more than half of the computers in the world today, some way or somehow, most likely to BIOS, the remote access controllers that we OEM out to other companies following the same model as well. And then here you can see the LSI Avago now sign in the top right there. And the reason we have that is kind of part of our, as in the StorTrends story. So we are a division of AMI, and what this started as, this group started out creating the Mega RAID controllers that LSI Avago Technology sells today. We did sell that off to them in 2001. We were the largest shipper of RAID controllers in the world, and it's still today one of the largest RAID controllers in the world. We brought that team back, and that's what developed the StorTrends product line SAN device that we're talking about today. Within StorTrends, 114 patents are granted, over 150 patents are actually pending, thousands of StorTrends installs around the world, and you can see all of our offices and stuff like that in that. So that kind of gives you just a little background. And again, like Tyler said earlier, if there are any questions, reach out. This is a lot better discussion and forum. If you do, just go ahead and ask your questions, and we can kind of answer them live. Just to dig into StorTrends, just so you kind of get an idea of just what we are, we have SAN products, actually single controller. These are all the dual controller products and how we kind of divide them up. The 3400 just all spinning disk, 3500 is our hybrid array, so it has a little bit of SSD enterprise class, and then spinning drives for back-end capacity. And then we have our newly released all-flash unit, which is a 3600, 3610, and the only difference there is the max capacity, and we just wanted to keep the cost down as much as possible for the 3600, so now you can kind of see that. And then we have expansion shelves going down horizontally. Here you can see just the comparison, just in case there is any confusion of exactly what the difference is. It's really just more of a right tier and then basically more overall capacity for the 3610. And of course, because it does support deduping compression, we have to basically focus in on more memory and CPU and stuff to process that I/O. So anyways, you can kind of see that here and how we kind of go. So now going into the actual PowerPoint and really digging into what we're lunch and learning here. So how do hybrid arrays, and we show the StorTrends 3600 here, or this is an all-flash array, sorry. How do these kind of fit into the current environments today, and how does this compare? So we use just a standard, we have a picture of an EMC rack there, but it's even us on our 3400 with an all-spinning drive array. You have to add these drives together to get that capacity up. Here you can see usable capacity of 40 terabytes, 5 shelves worth of enclosures. Of course, your IOPS, you're going to be looking at about 13,000, 14,000 IOPS. Of course, 15U worth of rack space, a lot of rack space wasted with, just disks and controllers and stuff like that. The yearly power, because you have so many units, that's where all the power supplies come in. You have dual redundant power supplies for every shelf, and that's where all this CO2 emissions, power, and all that stuff comes in. And you can see here, over $100,000 for this solution. You're looking at $3 per gig, I should say. On the all-flash side, on the right side, you have a 3U component here. It's dual controllers, everything's redundant there, and you can see kind of what your raw capacity is, 12.8 terabytes, and then given a very normal, we can get a 3.5 dedupe and compression ratio at any time, basically. With that, you can basically get a usable capacity of 40 terabytes in that same shelf. The latency, of course, is a huge difference from 10 milliseconds on average to about sub 1 millisecond. And you're looking at 6-7 times the IOPS here. A lot less rack space, a lot less power, a lot less disk spinning. Well, there are no disks spinning here. And basically, it's just a lot more affordable all around up front and then also in the back end there. And so now, if we talk about how does this compare to, server-side cache, we hear a lot of this out there, and it's like, where does this fit into all this? And they'll say, oh, well, if you have server-side cache, you don't really need, all-flash or, hybrid or whatnot. And so where does this, what are they focusing in on? It is obviously a different technology, obviously with the same goal, and that's how we're kind of comparing the two. So the raw capacity, you're looking at about 4 terabytes, and we're looking at 10% of the overall environment is kind of what they would scope for that. The rack space, there is no additional rack space, assuming you do have the space for it physically inside of your units for the SSDs or NVRAM, whatever you're going to put in there. And right, extra power, CO2 emissions, that's negligible really. But here you can see kind of where do server-side solutions fit in really well. And what you can see is with reads, as long as it's populated, which we'll assume that it is populated, online analytical processing type workloads, you're looking at 400 microseconds worth of returns. And now it's very fast. Obviously, NVRAM plays a huge part in that because they don't have to go, they're basically right on the bus instead of having to go through a server card or something like that. But the problem here is, on heavy transaction type situations, online transaction processing, you're looking at, a higher write rate when it comes to mirroring the data because you have to mirror it from this server to another server just to make sure that everything is redundant in that regard. So you do have a higher realm in that regard. And you can kind of see if you start, get a 50-50 average for reads and writes or a 67-33 mix, you're looking at 5 to 3.5 milliseconds on average for that. And, of course, you're going to pay for this. It's about $6 a gig, looking at the 4 terabytes and what the licensing would kind of go in there and all that stuff. And then, of course, back around to the all-flash array and how that really does kind of fit in there. So now, looking at the hybrid array, so now the 3500, and this isn't just our hybrid array, it's any hybrid array. Where does this fit in now? So, of course, the same spinning disk solution on the left, and, of course, you're back into a 3U environment on the right. The difference here is, accounting for misses and stuff like that, you're looking at about 3 milliseconds worth of latency that's guaranteed, basically. You're looking at about the same capacity. Your IOPS available, so it's 100,000 IOPS. But what we do is we actually focus in on, and we have a lot of intelligence around watching the historical and the current accesses of all the blocks in the environment. So everything that's stored on a StorTrends array kind of has its little metrics stored with each block. And so we'll say, okay, this is the heavier access blocks. We keep this in SSDs. You know what, this other stuff, it's not heavily accessed. We'll keep that down on spinning drives. And we do tiering methodologies based around that. So that's kind of how we work in that regard. And when tiering is basically, it is a slow function overall, we'll actually use 2 drives for caching, so then we can get an increased worth of cache space to kind of mitigate that buffer in between the tiering time that it takes to move newly hot access blocks into that tier. Of course, the rack space, the power, all that stuff is right there. And here you can kind of see you're looking at about $1 a gig versus $3 a gig there. Now, how do these two compare together? And this is the case for any flash array on the left to any hybrid array on the right. What happens, what we do is we only do deduping compression on the all-flash array. We worry about performance. You can look up our performance on Storage Review or this or that, so you can kind of see where our performance is, and we are very performance heavy when, that's our focus. So here you can see, well, what happens if I don't have that dedupe ratio? Say it is just an all-compressed environment, a huge file sharing type environment, something like that. You're not going to get a 3 or 3.5 to 1 or better, basically dedupe and compression rate, what we'll call a data reduction rate. So now that drives your capacity down to 23 terabytes. Of course, you're going to get the same latency. Your IOPS available and all that kind of stuff is still there. Now, however, you're at $2 a gig versus $1 a gig, and if that's an affordable solution for you and whatnot, to where the hybrid array, that is very predictable on what capacity you do have available and stuff like that. For us, obviously, we just want to fit the perfect thing for you. So we do offer both solutions and kind of just to make sure that that fits. Okay, so now talking about, SSDs and dedupe and all this stuff. So why isn't everybody doing this? Obviously, the price of SSDs, not cheap. If you look at a 4 terabyte drive versus a 200 gig SSD drive, these are two different worlds when we're looking at dollar per gig. The SSD endurance, now this is limited. You do have to watch and worry about, it's an absolute limited life cycle for how many times you can write to these drives and stuff like that. Do you have a question?
Yeah, we had a good one come in, kind of dating a few slides back, but it was where you were doing the comparison to the multiple racks of spinning disk arrays to the one rack of all flash arrays. And the quick question that came in was, is there any more vulnerability to having all of that data in one 3U form factor versus spreading out that vulnerability for possibly losing disks over 80 disks or however many are there? So I guess the question really comes down to how do we RAID protect these things, to ensure we prevent data loss?
Yeah, so effectively, your redundancy of disks, like kind of what Tyler's saying there, we both support RAID in this case. Within a rack, the difference is basically having these multiple shelves, the vulnerable links, the connections there and stuff like that. Everything is redundant in that regard. On our side, it is both controllers coming straight into the unit and stuff like that. So you really, when it comes to vulnerability, you're looking at about the same factor there. If motherboard fails or something like that, basically our unit will fail over just like the unit on the left would fail over. And stuff like that. And we'll kind of go, there's some slides about redundancy and stuff like that, or a slide about redundancy. So you can kind of see that in that factor. But at the end of the day, you're probably more vulnerable by having multiple enclosures striping that data, because there's just so many other things that can go wrong from the controllers on the head down to the expansion shelves or whatnot, to this shelf down below. So
right, so there's a lot more parts that can fail throughout the process, and a lot more moving parts that have to work just right in order for everything to stay up.
Right. And each of these shelves, it's striping data. So, if you want to talk about A backplane failure, every one of these solutions have the same vulnerability there. It is a low percentage vulnerability, but if you have a disk shelf, it's the only storage for that stripe of data. If a backplane fails there, it'd be the same reliability or vulnerability as you would have in this. So you're really looking at the same factor when it comes down to that kind of stuff. If you did have a follow-up, or if you wanted to say, oh, what about this or that, please email Tyler back, and we'll dig into it. No problem at all.
Absolutely.
Thank you very much for the question. And so now going back into the SSD, so we had the price, the endurance. Of course, there is a limited amount of writes that you can have to these drives. With enterprise class drives, you can write to these things 15 to 20 times over a day for 5 years straight, and then you'll hit your basically maximum life cycle for that. So there's a lot of writes that you can handle on the enterprise class drives. Now, some of our competitors only support basically, or they'll give you the cheap dollar per gig on standard MLC drives, consumer grade drives. With that, you can only write to that a fifth, the total drive size. You can only write to that on average a fifth of the drive space per day, every day for 5 years straight. So there is a huge factor there, and you know, when you do come down to it, you're easily going to write to it a fifth of the time every day for the 5 years. You may not write to it 15 to 20 times over every day for 5 years. So that's why we go enterprise class. That's why if you are scoping out another solution, go enterprise class in that regard. And yeah, it costs more money, and that's all there's to it. The drives are more expensive, and there's a reason for it though. So now we have this price of SSDs dollar per gig. We got to get that down. So now you want to look at dedupe, and it's like, okay, we'll reduce the amount of data that we put on this thing, and obviously there's duplicate data in the environment. You can compress this data, so you can really kind of shrink this as much as possible. Now, what's your dedupe and compression rate going to be? That's another battle that we have. So we'll talk about that here. And then the performance of dedupe, you know, there is a reason that we're only supporting it on the all-flash array. There is an overhead with that to spinning drives. We make sure that performance is our top priority, in particular latency. So we do make sure that we only do it on the all-flash array. There is performance overhead in doing it to spinning drives. Just look at our competitors online if you look at a comparison of performance, and you'll see what that is. Okay, so now we always talk about IOPS and what are IOPS. Now, what about latency? So for kind of perspective, so we talk about IOPS, say 100,000 is kind of that golden magical number. I hear it all the time from customers. Hey, you know, I don't know. I just need 100,000 IOPS, and we'll go from there. So what does it take, SSD or spinning drive-wise, to get to 100,000 IOPS? And so here you can see kind of the factors. Obviously, these boxes aren't to scale. That 4-disc box, that would be a lot slimmer if it was to scale. The 285 discs of 15K, so literally you can get 300 to 350 IOPS per drive, at least with a StorTrends unit. Of course, not everybody's the same, but again, we worry about performance, so our drive performance is up there. But anyways, so 300 IOPS, somebody will tell me 200 IOPS. I'm sure they'll email Tyler here, so that's why I'm saying that. So anyways, 300 IOPS or so, 285 discs, and so you can kind of get there by striping all these discs together. And then we do focus this on kind of a RAID 5, RAID 10 type situation, so the right performance is factored. But this is just for read, so anyways, and really it would be 2 SSD disks to get to 100,000 IOPS, another side note. So anyways, 400 disks of 10K, so literally it's spinning slower, 2/3, I'm sorry, slower, and so literally it does take that many more drives to get up there. And then of course 7K RPM drives, it takes about 500 disks. Now who's going to do 500 disks? You can ask a lot of NetApp customers that go out there. I've actually run into multiple customers with well over 500 disks striped together to get this I/O load up there. And it's absolutely ridiculous in that regard, especially just looking at, I'm not that much of a green thumb kind of guy or worried about the world dying tomorrow, but that's ridiculous when it comes to the output and the waste there. Now, the technology may not have been there when they bought that, so here we are today with SSDs. And then, of course, corresponding latency at the 100,000 I/O load. This is where your SSD latency would be. This is where your 15K latency will be, 10K, 7K. Now, if you go above and beyond that, if your latency is higher than that, you're overloading those drives, even though you may be getting only 100,000 IOPS out of them. You're overloading them, so now your queue's falling behind the queue depth. That's falling behind because basically the server wants to do more, but it's waiting on responses from the storage. So that's where your increases of latency come from. So anyways, here you can kind of see what you would expect at that load. And obviously if somebody's targeting 100,000 IOPS, it's just a peak. An average I/O load is probably less than that. And then, of course, you know, their peaks are always right there. So anyways, you can kind of see how these correlate. Again, ask any questions. So now, if you go above and beyond that, what's happening here? So, of course, the queue depth is falling behind. So basically, the queue depth has a maximum amount of IOs in queue that it can send off to the storage. So if you go above and beyond whatever your certain storage is, so say you have 16 15K SAS drives, something like that, you know, they can get about 5,000 IOPS for that system. Let's say a RAID 5. Doesn't matter between RAID 5 or RAID 10 if we're looking at reads. So that 5,000 IOPS. So now, if you're looking at, say, 4,000 IOPS as your peak and you have a 5,000 IOPS system, in general, it's not to scale, you'll be under your 7.5 milliseconds and you'll be around 5 milliseconds. Looks good, right? Everything's happy. Now, if you ever go above and beyond that, you're going to start hitting the maximization of the drives, and so then it's going to back up on the server side. Now, of course, that queue is limited, and so basically, eventually, your queue will start filling up, and so that's where all the I/O starts waiting, and that's where that waiting time is your latency of the environment. So when you look at this, you know, 5 milliseconds. I had a customer, this green box up top, good and fast is the normal piece, but he wanted snappy storage. He was like, man, make this thing snappy. So we had to upgrade him because basically he did have spinning drives, and I was like, look, you have X I/O load, you have X drives, here's physically what these drives can do, here's physically what SSDs can do, and it was more of a money thing originally when he got into it. You know, 2 years later, he's like, hey, look, you know, everything's working fine, let's get this thing upgraded. So anyways, he wanted it snappy, and he got it snappy once we upgraded his environment and the drives that he had for that same workload. 5 to 20 milliseconds, this is most likely where everybody's at today without SSDs in their environment, just because the hard drives can just only respond so fast. Even with a 15K SAS drive in 7.5 milliseconds is, say, the latency at 100,000 IOs. Now, no matter what, though, you're never going to get below maybe a 5 or 4 milliseconds, even at one IO, just because it does take so much time for that drive to basically spin, seek to the location, and then respond back. To where SSDs, obviously, there's no seek time, there's none of this wasted effort, and so it can respond back even with one IO to 100,000 IOs. So 5 to 20 milliseconds where most everybody's at, and then, you know, it's okay. Everything runs fine. As long as you're not exceeding what the drives that you have installed can do, you're absolutely rolling. You're absolutely fine. Everything seems fine and dandy. Now, going past 20 milliseconds, you know, most likely it's, oh, this guy runs this report and it takes, you know, 15 or 30 minutes and, you know, it slows everything, bogs everything down. That's where that flow comes in. Obviously, if you have multiple guys running reports like this or what have you, you start getting over that 50 milliseconds. And then, of course, when you start getting into the 800 milliseconds or 5 seconds, you start having even worse timeouts. For the VMFS would be an 800 millisecond timeout. If you consistently get that, it'll start freezing that. And then 5 seconds, which is basically 5,000 milliseconds, you'll be looking at a lot worse situations when it comes to actually just getting forced out of the VMFS.
Yeah, James, sounds great. A little off topic, but I had another good question come in. This one more relates to kind of back to power consumption and looking at like the hybrid array, like you mentioned, versus the all-flash array. Which one of those consumes more power, and do you know if there's a reason behind that?
Yeah, absolutely. So just conceptually, the hybrid array has hard drives in there. say 10 or 12 is kind of our standard. With those, they drive more heat, but they are also spinning physical platters and stuff like that. So they do draw more power, create more heat, which is another problem. You have to cool this and all that stuff. So that's kind of where that extra power loss of efficiency comes from when it comes to the hybrid. But in general, if you're comparing 1 3-unit, even with spinning drives or not, to 5 units, that's where the bigger factor comes in anyways.
Very cool, very cool. Thanks, James.
Got it. Okay, so how can we fit this into SSDs and make everybody snappy and happy and good? So inline dedupe and compression, I'm sure everybody's heard about it. It's not a new thing anymore by any means, but not everybody has it, and that's a fact. Who was it? Permabit actually came up with these numbers of just kind of, given the current, status and how much is growing data-wise, where are you going to end up, say in 5 years or something like that? So you can really see, I mean, they're getting into 75% of data is really duplicate data. That's based on the historical here. And so if unique data created increases at its current rate, and it is exponential as it sits, basically you can kind of see how much duplicate data there is and stuff like that. And you're looking at 10 zettabytes of total overall data to about 44 zettabytes if you don't dedupe this data and try to reduce it down. So obviously there is a huge data efficiency factor there that overall we need to work on and look at. God knows how many, when I take a picture with my iPhone, how many copies of my pictures Apple has and stuff like that just to make it available, So, but redundancy is one thing. Doubling that is a whole different thing. When you're looking at 75% of data growth, the problem is they're doubling already double data anyway, so it's an even worse factor. Okay, so the idea with dedupe and compression, your repeat data, you're never going to write this to disk. That is a huge endurance increase. So you're looking at SSDs, and how many times you can write to them is very limited. Now we're reducing how much we can write to them. Say you're looking at a 3-to-1 ratio, which is very standard. Now, for every 1 block you have, you would be writing an additional 2 times. So now if we have a 3-to-1 ratio, say our enterprise SSDs can get a, we'll just say 10-time drive write per day, and you get a 3-to-1 ratio, you're looking at 30 times now. So now it's getting a lot better in that factor. And then even consumer-grade drives, you're looking at, instead of 1/5, you're looking at 3 or 4/5, just depending on what your ratio is and stuff like that. And then even better, so if you see a redundant block of data, you don't even have to write it to disk. So now there's a huge performance increase. It's literally touching the RAM and saying, oh, no, we already have that. It'll do a RAM update and then acknowledge that I/O back. So you don't have to worry about those kinds of things kind of hindering what you have there. Now, of course, we're trying to reduce the number of blocks in this environment by deduping them. So we're saying, okay, whatever comes in, say you see these red, blue files, we kind of kept it generic here, but say they are the same file over and over. And so we're looking at individual blocks within the file. So if it is, say it's a 1 meg Word doc on the top left there, that red file. Now, 1 meg, now you divide this up into 4K blocks. Now, say you just changed the header of it, the title of it. No big deal at all. The rest of that data is all completely redundant there. So now version control really gets down to a super granular level versus a file-based dedupe. Now, of course, anything that is just absolutely completely duplicate, it's 100% duplicated. So now what you can see on the right here is literally a 2-to-1 dedupe ratio going from those files down to just storing the one file. I know this is dumbed down for some of you guys. Some of the other people might be like, hey, I really actually don't know what you guys are doing. So this is trying to kind of bridge that gap there. So, of course, it doesn't matter for PowerPoint, Excel, Word docs, Exchange database, so then, of course, emails. Doesn't matter about any of that kind of stuff whatsoever because we are just looking at blocks. Now, we also do compression. So what are the issues with compression? Major issue is the CPU and memory overhead with compressing data. There is a huge overhead with that. So what we do to circumvent that is basically dedupe first prior to compressing anything. There's two huge factors in that. A, we get a better dedupe rate, which we'll talk about here in a second, but also we're not just compressing data that it doesn't need to be compressed, so you're wasting that CPU and memory on that. So anyways, that's how we do it, and it is the absolute most efficient way to do this in that factor. The other thing is the 4K blocks. So we talk about inline deduplication and compression. This is always in line, and there's a huge note there because some people do it after the fact and they're say, hey, we'll do garbage collection later, this and that. Well, A, I have a lot of customers, they would never have time to do garbage collection of their dedupe and compression. But then also, when you're doing that, what happens when you really start getting up there in capacity and then, hey, look, I don't have any more capacity to do your garbage collection because you're not deduping and compressing at that point in time. So now you're doing additional writes to disk, you're having to do additional computations down the road, and then even so, while you're not doing that, basically you don't know what the duplicate data is in there at that point, so huge factor there. And then looking at, perfect world dedupe and compression rates. Here is just compression alone, so that's kind of where this factor is. Here's deduplication, so now here's, and it's just deduplication alone, not including it. And so now when you combine those two technologies together, where's your overall level? You can see with backups, it's a perfect world environment. Backups, there's a lot of redundant data, and even better, it's usually at a 64K block size, the NFS or NTFS or whatever the file system is, usually at a bigger block size there. Actually, NTFS is going to be at 4K, so it's going to be in perfect line there. But what it'll do is, like a Veeam or like whatever, they'll mark off blocks or segments or files that are actually duplicated, or changed, I'm sorry, I should say. And so when they mark off that file, they are storing the whole additional file. So say it's 1 meg file, all that additional space is wasted. So what we can see is actually the difference in space and, of course, the duplicated data in there. Now, backups for an all-flash array, not reasonable. A perfect VDI environment, you can get a 33:1. Now, that would be 100% the same exact desktop, stuff like that. The norm is about 10 to 17:1. Database environments, you can see 15:1. Now, this is with workflow. There's a huge note there, and, of course, nobody talks about what these perfect world numbers are that spit out there. I've told you, in general, we're looking at a 3, 4:1, and, on average, in good environments, you're looking at a 7:1. But, of course, there are some that are 2:1, and it's just compressing the data. So with workflow basically means, if you have, say you have a dialer program and you have a cold calling environment, and what the dialer program does sometimes in some environments, and it just depends on how yours works, it'll actually spin off the database as a read-only database for each individual user. So now you're duplicating all that data, all the databases for each individual user. Say you have 50 users, that's a 50:1 reduction right there for that database while it's live, stuff like that. And then it'll mark off and roll in changes once those users get finished with it. So that's kind of what workflow is. Another version of workflow is if you have a reporting database or something like that, and you spin that database off from yesterday or whatnot, so basically that would be a duplicate of that. So if it's just one single database and that's it, you're going to be looking at a 2:1 ratio. Exchange environment, so there's a perfect example here, so this 9:1. So we had this customer, it was a 9.5, 10 terabyte database, we'll say. What they had was, with Exchange, the default checkbox item is to have it compress the data. Well, what it did was it brought it from 9 to 10 down to 6 terabytes. Hey, it's not bad for Microsoft just rolling that in there. So they put that database on our environment, and it only went down to 3 terabytes. And they were like, well, that's a 2:1 ratio from the 6 terabytes of data that you're getting. What the heck's going on, right? Well, of course, it was compressed data. Had them decompress that, and so now it's just the raw database. That 9 to 10 terabytes literally went down to 1 terabyte. So now you are looking at a 9:1 ratio, and overall, for your infrastructure, it's more efficient. Now, with that 2:1 of the compressed database, user directories, this is where this fits in, because user directories, in general, you're looking at docx, you're looking at XLSX, PowerPoint, all these things are compressed data. On compressed data, you don't get a good dedupe rate unless it's the exact same file, and then, of course, you're looking at about a 2:1 ratio, which is the same you'll see on any of these if you're looking at compressed data. So that's kind of how that factor rolls in there. And so now, how does this apply to you? We'll kind of quickly run through, for desktops. You guys know what the VDI environment is if you have that. So with the hybrid array, the only additional overhead that there is management-wise is saying, okay, we have to pin these volumes in different levels and say, hey, look, my tier 0 is my SSD space. I want my replicas up there. I want my temp OS space up there. But however, what my user space, that can do like a middle ground. And of course, normal environments only have 2 tiers, so you can kind of split this up any which way. And we do support up to 8 different tiers, so you can also get even more granular. But one thing that's wasted to the golden images, we don't want that to be on SSD space. It's not accessed heavily. The link clones access the replicas. So what we do is basically keep the golden images pinned down low, the snapshots pinned down low, but then have those replicas up there in SSD space. You don't waste that golden image space on that. Now, of course, with an all-flash array, you have less to worry about here because you do just have 1 tier. And there were a lot of things with, hey, I do my virus scan or my check on my golden image, stuff like that, all that. So now if I take a snapshot, if I take a golden image, it's all SSD space in that regard. So very simplified version there. If you're looking at databases, and literally there is hot access data in the database and then unaccessed data in the database, and you can see the green versus the blue there. And it is a higher percentage, and we'll kind of actually show that. But the same thing here, you pin certain volumes in certain levels, and you can kind of go from there. Or obviously now, you can basically just have all in 1 tier. So it is a huge factor when it comes to performance-wise. And say you commonly take snapshots and roll off a dev database or a test database, now you can get SSD performance with that from that snapshot and stuff like that. So you have to kind of worry about those factors. Another thing that's been huge for us is our backups and disaster recovery solutions to where we do disk to disk. We don't actually require exact duplicate units, so if you did have an all-flash array at the primary and you just had a standard DR site, we can actually do a single controller spinning drive that we've been selling for the last 10 years. You can put that on the DR site, no big deal at all. And what we have is wide area data services in the middle there, the WDS. And we have our own WAN optimization, which is mixing UDP and TCP together, absolutely as efficient as possible using the link. And then we have compression, deduplication, encryption as optional, just all space savings. You do not get a better RPO, RTO at all, SAN to SAN, other than with us here. And of course, everything's all included too, so that's another side note with everything. Another thing, so if you're looking at the DR side, it's like, man, I have this database, I have this VDI, say Microsoft Dynamics, Exchange, what have you, and then I have this DR space, so it's an active-active kind of site situation. The DR space, you can pin that down low, and so be it, so you don't waste that space on a hybrid. Of course, with an all-flash, if you did fail over to this site, now you don't have to worry about the time that it would take to cache and tier that DR space up. You basically, everything's on SSD, it's fully available in that regard. So how do we know, what the situation that I'm talking about with data and stuff like that? And we have the StorTrends iData tool. You can go to stortrends.com, resources, and you can see the iData tool, and then we also have a dedupe analyzer tool. The dedupe analyzer, it'll give you an idea of what dedupe do you expect from, a certain database or this or that. And of course, if it's just a single database, you're not going to get a lot of dedupe out of it. It would be just compression. And this only does dedupe. We just add in compression because it is a very standard fact on that. And then with the iData tool, we really dig in, and you can see here, you can basically select the servers that you want to monitor, and then you basically put in the credentials, and if it's a vCenter server, it'll automatically add in all the hosts for you and stuff like that, and basically run it for a week, and it'll generate this report on the far right, and you can kind of see your IOPS, capacity, utilization as an overall view, as well as by server, and then also by VMs and stuff like that. So it really digs down deep. And of course, you can use this just for, obviously, VMware on the bottom right there. Even for desktop deployments, if you don't know what profile you need for certain users and stuff, you can actually use that just to profile out for VDI, and of course, SQL Server Exchange, whatever you want to do there. And then what do we get out of this? So initially, I ran these numbers just to kind of compare the iData tool with what we see from our actual customers. And actually, you can see a very low percentage of customers, percentage of data anyways, have over 100 accesses within an hour. Now, 100 accesses within an hour is very, very minimal, especially if you divide that up by minutes and seconds. You're not even looking at a 1 IOP average. So you can kind of see what percentage it is. And what I wanted to see was, you know, a lot of the generic solutions engineers, they'll just say, hey, just put 10% out there, they'll be good on that SSD space and whatnot. And you can see here what's accessed within an hour and what's accessed within a day and then so forth. And then the cold, the gray, I mean, this is absolutely unaccessed within a week's worth of time. So in that, you can actually see 10%, as it turns out, is actually a good number. So it actually just validates that point. But, you know, that's a whole side note there. But really, for overall accesses with SSDs, you're really looking at well over 1,000 IOPS for that type of environment. So you can kind of see where this would be at. And you can really get away with a 5% or even less. It's no big deal at all. Now with databases specifically, that last one was with infrastructure environments, you can actually say, okay, they're a lot more lean. They're very focused. It's within 1% there for that. So you can actually get away with a lot less in that just because the database is doing a lot of work there. But, you know, even if you get 10%, it's a great buffer. It handles any accesses within an hour and almost half the accesses within a day even. So just kind of depending on, you know, how much money you want to throw at it almost, you know, kind of situation there. And then, so now combining these two charts just to kind of get an overall average of where are we at. So say you're looking at that 40 terabyte solution that I had up front there. You're looking at 3 terabytes worth of space that would fall within that percentage there, just to kind of hit an average of infrastructure and database environment. So 3 terabytes, I mean, to get up there, you're looking at either, you know, 4 or so 800 gig drives plus some caching drives, or, you know, you need to worry about, you know, kind of doing a small end all-flash array as a head and then, you know, capacity on the back end. But either way, I mean, it starts getting up there price-wise. Say you wanted to get, you know, everything that's accessed within a day, and that's 12 terabytes worth of space. Now, that's a lot of data to basically handle, or a lot of space to be able to buy, basically. So there's a huge factor there in, you know, what you're going to do. And this is absolutely where all-flash array comes in. Everything's covered, basically, in that regard. And what we're doing is we're taking of those 100-plus IOs within the last hour, and we're saying, hey, if, say those are all writes, the worst-case environment, we'll just throw those into enterprise-class drives, and then the rest of that data, we'll throw that in read-only drives, consumer-grade drives. We can read from these consumer-grade drives as many times as we want, absolutely no problem at all. But, of course, we have to get the capacity up. Well, we have dedupe and compression for that to basically get that going. So you can kind of see how this kind of fits in here. And then, you know, how do we really do this? I mean, this is all data analytics on our side. What we're doing inside the unit with your blocks, we're saying, okay, historically, these are all read blocks. We're not going to waste the enterprise-class drives on these blocks here. Now, why? This one's heavily written to historically. Geez almighty, we need to keep that in the right tier on the enterprise-class drives. It's absolutely a perfect world for maximizing the space of the consumer-grade drives and the dollar per gig advantage there on SSDs, but then also maximizing what the right tier does within enterprise-class drives. They can handle a lot more endurance. Now, even better, okay, you're talking about historically, what about now? What if that Z block gets written to all of a sudden? I don't want that going to my consumer-grade drives. It's very limited. That's fine. That's why we have this enlift cache algorithm that will automatically see that it's a write block coming into what was previously a read block, and now it'll actually put it in what we call enlift cache and just auto-populate it into the right side drive. If we then realize, hey, this thing's all of a sudden written to commonly, then we'll just populate it into the right tier and just promote it effectively. And then if it's just continually read from again, then we just push it back down to the read tier and done. So that's kind of how we do that to kind of increase redundancies.
Cool deal, cool deal. Yeah, well, not really a question, just a quick reminder, everybody. We're coming up on a quarter till, and we'll end this session promptly at 2 p.m. Eastern Daylight Time. So if you have any questions based on anything James has said over the past 45 minutes or so, please go ahead and shoot those over to us so that we can make sure that we answer those on air while you guys are listening. If you get in a question towards the end and we're not able to answer it on air, we'll definitely shoot you over the answer via email this afternoon, just because we want to make sure we answer any and all questions that you guys have. But if you have some now, go ahead and shoot them on over, and we'll get to working on those for you.
Absolutely. And then just to talk about our support, what we have available, 1 to 5 year terms, 24/7 technical phone support, next business days is standard, and then of course you can extend this. And then StorAid Plus supports 4-hour on-site. There is personalized support here. We do have a pod of engineers that basically kind of has an expert for each different workload type, just depending on what you have. And that way you're familiar with who's answering the phone, and it eliminates kind of the simple questions that would come out of that. And they're all hosted in Atlanta, Georgia, so that's a huge factor there. You're not going overseas, and there's no, barrier in communication there. Outside of, maybe some of them have a little southern drawl or something like that. Email support, 24/7 email, fatal alert monitoring. Emails go to yourself and AMI, so we're all fully aware of what's going on. And then in that, we have medium error and endurance alerts from the hard drive. So we'll actually proactively replace drives automatically. You can basically rebuild on your time and not worry about anything else. When it comes to hardware, I was actually talking about this slide earlier. I wanted to make sure that we understood, everything's completely redundant inside this unit. The controllers, power supplies, obviously CPU, memory, all that stuff. And then, of course, the SSDs, the hard drives, everything within there. Basically, you can absolutely have RAID redundancy and automatically fail over and stuff like that. Here you can see there is an optional spare parts kit if you just want to have this stuff on site. Also, the StorAid Plus support comes with that standard.
Hey, James, we had just a great question come in just a moment ago, and I'll go ahead and read the whole thing out to you, and you can kind of give me your take on it. But like other vendors, do you treat SSD drives as SSDs, not as spinning disk drives? So basically, are they just slapped into the case, or do we actually approach an SSD differently from a software perspective?
Yeah, and that's actually one thing. It's one of the problems with the legacy vendors, the Goliaths out there. They didn't design their product around SSDs. They did just kind of slap that in there. So basically, when you were looking at this, we are watching and monitoring the endurance and focusing everything in on what we're writing to them and how we're writing to them. So we are absolutely doing full stripe writes, so we're not kind of randomly writing I/O to the blocks. We're fully aware of, where this endurance is wearing out and stuff like that, so we can expect and proactively understand what's going on within the unit. To where, there are a lot of situations to where you are correct that some people have just slapped that in there, and we absolutely have really focused in on spreading that out. And then every year we have kind of a review, performance and health review. It includes getting a debug dump. It's literally just click of a button creation, and it'll automatically upload it to your AMI FTP upload location. The StorTrends engineer, they'll check drives, capacity, latency, all that stuff. And then, of course, we'll have updates, either the triggers updating or the annual review. And basically, you can download and upgrade the software with zero downtime. If we go a step further here, so kind of how we step in and how our technology really is, it is in there. It's absolutely proven. We have storage reviews article and they've taken it in their lab and actually pinned it up against the other vendors, so you can actually see with an exact data set that's the exact same between all these vendors, where do we stand in with them. And you can see this is the latest chart. If you go on to storagereview.com, you can see the StorTrends review. You can also see the other guys' reviews and stuff like that. And this is just the chart from the latest review. And you can see 6,200 transactions per second with a 30K virtual user load. And you can also see the latency, which is 41 milliseconds, which is still the fastest within hybrid arrays here. And so you can kind of see what's that latency look like in comparison to everybody else. And so it just shows we are so focused on performance and making sure that these things work. And then you can see on the right the VMware vMark VM mark, I should say. You can kind of see who didn't even make the 8 or 10 tiles there versus us, where it's the top of the mark for every one of those. So just kind of where it stands. And then real quickly, our installations, we have a bunch of different verticals, a bunch of different customer types, and they're all doing different things. You can see here, like Iconos on the top left, they wanted the snappy storage. You can kind of see what their capacity looks like. They're doing all SQL VMs and databases. Aquatech on the top right, they're a pipeline manufacturing company. And they're using us for centralized storage and a little bit of VDI, replacing a NetApp there, Dot Hill on the left side. And then there's like TGI Office Automation. They're a repeat customer. They're actually with us for the previous iterations of our units. And they just wanted a faster unit. They wanted more SSD and all that stuff. So you kind of see they have multiple sites and what they're doing at each site, and they're replicating both ways. And then University of Texas, Dallas, 70 terabytes worth of space and doing a lot of, databases, brain research, functional MRI images, all that kind of stuff. So, and they did a huge consolidation within their infrastructure. So yeah, so we'll see. Do we have any other questions by chance? We can dig right into the demo.
Yeah, well, let me go ahead and ask you one, just kind of as we're getting into the demo a little bit, just so you can kind of answer in stride. But one of the questions we had come across very early was, how has iSCSI evolved over the most recent few years, and kind of what are the projections for the iSCSI protocol? Where is it going in the next couple of years in terms of bandwidth and throughput and all that sort of stuff? How is it getting better?
Yeah, so iSCSI, so the limiting factor with iSCSI before was the bandwidth that was available with it. When iSCSI really got kind of more mainstream, it was limited to a gig bandwidth. 10 G's fairly recently, well, now it's just straight up getting adopted all over the place, but it's fairly recent compared to, Fibre Channel. And then what people have done with Fibre Channel is just kind of grown with Fibre Channel because they've already had it. And so now with 10G, though, so Fibre Channel is now up to 16G worth of throughput. However, that's a huge adjustment in price when it comes down to upgrading to that. So if you either do that, the 10G is more cost-effective. In general, the 8 gig fiber and the 10G iSCSI, basically, it's absolutely fine when it comes down to what throughput requirements there are. And even so, right now, I actually have a 40G iSCSI switch in my lab. So now we're jumping up, forget about 16G or 20G, they're going straight to 40. So now it's just completely surpassing what's going to be available with Fibre Channel. So there's absolutely going to be a mainstay of movement there, especially going into 40G and stuff like that. So anyway, yeah, we're absolutely seeing the future in iSCSI and all that stuff. Here you can see on the screen, let me just go to full screen and make it a little bigger. So here you can kind of see just one of our units. You can see the actual I.O. going to the drives. We can flip this around to the rear view. Okay, I've pulled an interface just so you can kind of see what that looks like. And so you can kind of see what, interfaces they are, what networks they're on and stuff like that, if they're teamed and all that stuff. And then if you did have multiple enclosures, they would just populate right here. You select them and then kind of go about that way. You can also see your throughput utilization, all that kind of stuff right here. So kind of gives you an idea of where you're at. You can see left controller, and you can kind of see this is read-only I.O., and you can see it's only coming from our consumer-grade drives, which is very important to note. So we are actually watching the I.O. We do have write I.O. as well going on here, but a majority of the I.O. is reads. It's heavy reads, and we're promoting that effectively to the consumer-grade drives because it is more efficient on endurance. So event logging, hardware health, this right here, all kinds of different stuff available. We have a SSH login if you want to do any scripting from directly here. The dashboard, like I talked about, debug dump. You basically just click, create the debug dump, and then either upload it FTP, or if you don't have a management port or something like that on the network, just download it locally and kind of go from there. Updates are very similar, just obviously doing the reverse. It's uploading something back. So you can put in the FTP information or just simply have a patch, choose file, and then kind of go from there wherever the file is located at. Yeah, and UPS support. We support SNMP, UPS, network UPS, USB, just depending on what you want to have or what you have in your infrastructure today. So you can be aware of, hey, is the power out? Do we need to automatically go to write through? All that kind of stuff. So here you can see storage statistics, which is that first screen. You can kind of see what your overall data reduction rate is. And so physically, I'm using 72 gigs worth of space, and I've allocated 579 gigs worth of space. So the initiators and all that stuff think that they have 580 gigs, but we're really only using 72. So it is a huge space savings when it comes down to that. And you can see here, I have some demo volume, some night I/O thing. I sometimes do later demos and stuff like that. And then this I have just read-only, and so this is actually what we're talking about with that. And then this Run 3600 just has a bunch of VMs on there. If we go into volume statistics, so you can see each individual volume, kind of see what the latency looks like for that. So the Run 3600 is down below. You can kind of see, okay, where's my latency at? Reads, writes, it's a lot of writes. And then what's the I/O, what are all these factors here? So you can kind of see that. And then also, so now this is a whole different I/O load, and you can kind of see, okay, 0.31, 8800 IOPS, all that kind of stuff. So, and it is 100% reads. Now, that being said, we'll go to the Run 3600 and see, okay, where is this actually saving space at? You can see map space, 10 gigs on Tier 1. So now this one, which is running all the I/O, 8800 IOPS you saw, 100% in the Tier 2. So we are actually, this is where the analytics come in. We're literally looking at these blocks within the environment to say what sufficiently need to go where. And then, of course, things like snapshots you can see here. We do support VSS-aware snapshots, so if you want to have, Quiesce databases and stuff like that. And then we can also do multiple levels and stuff, so you can kind of check what retention you want. So you want it for the last 12 hours, 5 days is fine, 5 weeks is fine, doesn't matter. Just update schedule and go from there. And then, disk latency, workflow management. So we are actually watching the I/O load by day and by hour and saying, okay, how much background function should we do at this point in time? And so during the peak of the day, we actually reduce how much workload in the background that we do versus, the middle of the evening and stuff like that. And here's just another view of, okay, what blocks are getting access more heavily and written to. These are the writes, the Tier 1, which is just the enterprise class SSDs. And then the Tier 2, you can see here, 11 gigs worth, basically heavily getting hit by just 100% reads. And that's over 20,000 IOs in the last hour. So we are absolutely watching all these things, and that's pretty much the only way to prove it or show you, I guess, per se. And then, of course, whatever mix in this environment would be all reads. In a normal, natural environment, you can kind of basically see that stuff. And then, of course, there's wizards basically to create anything you need. We watch all smart analytics, all endurance levels, all that kind of stuff. So you can kind of easily see that. And then we'll just, oops, I can't type, do be lunch and learn. And we'll just create a volume real fast just so you can kind of see it. Save the cluster environment, add to list. And you just keep on going down from there, hit finish, and it literally will create the volume. Everything's completely fully available to connect to and all that stuff. We don't require adding in initiators. We don't require any of that stuff. But we do, of course, support things like CHAP and all that kind of stuff. So you can kind of do all these things here. Inside of that, that pretty much sums us up and stuff. So if nobody else has another question, I'm good. Tyler, did you have anything?
Yeah, let's just do one last question as we sign off here, and that was this one just kind of going back to the registration. And, what sort of, security is a huge issue for people nowadays, and with the migration to Flash, are there any additional security concerns or new things to be proactive with in terms of security when moving to a Flash-based solution?
Yeah, security on a Flash-based solution, there's no difference there. It's really, iSCSI would be the difference, basically. And then in iSCSI, you do have CHAP authentication and stuff like that. So you can, say we want to lock this unit down, which is connected right now to everything. But let me see if I can find not connected right here. And so basically, if you did do that, you can select which initiators can log in. Say you do have a management port out there, so then you don't want just random anybody's connecting in. You can lock it down via this, and then you can also lock it down within your control panel. And so with portals, we can actually disable the port 3260, which is the iSCSI port, for, say, a management NIC, which I'm not going to do here because I'm not sure if I'm using them right now. But basically, you can lock all these things down so that nobody can access, basically, security-wise, your volumes and your LUNs and stuff like that.
Very cool. And one last quick note, in case anybody's interested in pricing at all for these StorTrends arrays, just want a ballpark for, I mean, heck, what are these things retail for? What can I expect to pay if I were to want to purchase one, in a few months or, a year down the road or something like that? From once you click out of WebEx, you'll actually be escorted over to the website, so you can, feel free to fill out our price quote generator, and we'll send you over no obligation, rough estimate quote, no final pricing, obviously, anything like that, but it'll at least give you a good ballpark for what to expect from one of our arrays. Other than that, I think that's everything I had for the good people. James, did you have anything for them?
No, just thank you guys for coming in, listening to us. Reach out with any other questions. No big deal at all. I always have demos available of any and all of our units. If you want to dig into VSS, if you want to dig into snapshots, recovery, if you want to do a DR wizard, anything at all, no problem at all. I can hook it up. I also have a web client right here that we didn't even touch. So basically, we can log in through this, and you can kind of see how that works as well. So a lot of stuff that we didn't even remotely get to that we can always show. So yeah.
Sure, I know we threw a lot at you guys today, but thank you so much for attending and participating and asking great questions and everything like that. It was a pleasure presenting to you today. Feel free to reach out anytime if you have any sort of questions or anything like that. I'm sure you all have my contact information by this point. So other than that, we're signing off, but thank you guys so much. Have a wonderful day.